Hi, I'm Amirhossein Deljouyi. In this video, I will present my master thesis. My master thesis topic is model-driven methodology for developing RESTful web services. My supervisor was Dr. Ramsey. My presentation contains 5 parts. First, I introduce main problem, then I explain the proposed framework and process. Finally, I show the evaluation part and conclude my contributions. Introduction. In my master thesis, we use several concepts. My master thesis was a journey to learn and get deeper into approaches and architecture. We started with RESTful web services because RESTful architecture is simple and provides comprehensible APIs. The main issue of RESTful web services is repetitive tasks. So we decided to tackle this issue with model-driven approach. The model-driven approach generates web services by models. It starts from abstraction models to generate codes. It could improve automation. When we went further, we found out rich domain model is necessary for web services, but existing methods didn't cover that. The domain-driven approach can be an effective approach for providing rich domain model. Nowadays, architectures like microservices and event-driven are essential for modern web applications because they can handle non-functional requirements like performance and scalability. But existing methods for generating RESTful web services do not cover the development of web services adequately. They do not support common architectures of modern web applications. They fail to support high-level modeling. Generally, I can say there is no comprehensive methodology for generating RESTful web services, and our goal and our object was propose a model-driven methodology for developing RESTful web services. A part of the study was a literature review, and I evaluate related works by 4 criteria: in general software development, model-driven web engineering, and RESTful web services. 2 criteria existed before, and we developed 2 other criteria, means model-driven web engineering and RESTful web services. As you can see, existing methods can cover standards very well. They got a score C, and it means they didn't cover that. Proposed framework. We propose a model-driven framework with 4 levels of abstraction. At the first level, we extracted the domain model with textual requirements and activity exorming models. These models transformed into the ontologies. Ontologies are ubiquitous language for our framework. Then a DSL is created from linked ontology. The focus of the second level is on RESTful architecture. At third level, we have concrete models. This set of models can transform into models of code generators. Finally, code generators generate the code. Also, we generate security aspects manually, because no one of the code generators didn't support that. We developed some tools for the framework. An annotator for annotating textual requirements and generating a static ontology. And we developed a new model called activity storming, and we developed a graphical editor for that. Also, we developed command line interface for the code generator, and you can use that instead of the code generator directly. The meta models are available for use in the other projects. We use three languages to transform models. Two of them are general purpose programming languages. We evaluated the possible transformation languages, and we decided to take advantage of Eclipse Epsilon because it has many capabilities. We used Python for parsing annotations and generating a static ontology. We used Java for ontologies transformation and generating a DSL for CIM. Also, we used Eclipse Epsilon for transformation models to models, PIM to PSM and PSM to code. Eclipse Epsilon, it is a popular tool. It supports model to model transformation. It has a strong support for EMF, and it is Java-based scripting languages. And it is very useful because we use Java for abstraction models, and we use Eclipse Epsilon. Architectures are important in the framework, and we supported onion architecture, event-driven architecture, and microservice. The web services generated by the framework are based on onion architecture. Also, we consider the separation of concerns. As you can see, the REST API layer is top of the layers. On the top of the layers, next we have service layers and a domain model layer. Also, we supported architectural patterns such as CQRS and event sourcing. This picture shows the architecture of CQRS. In that architecture, command and queries are separated. In the first level, we model domain with textual requirements and activity storming. The textual requirements models the structural aspects of the system, and activity storming models the behavioral aspects of the system. Then knowledge stores in ontologies. Finally, linked ontology converts to CIM DSL or YAM DSL for representation of PIM level. The video shows the process of the textual annotation and generating a static ontology. A static ontology was generated. Activity storming. Activity storming is a combination of activity diagram and event storming. The activity diagram has formalization, and the event storming covers domain-driven development concepts, but we wanted both. We used Eugenia for creating a graphical model editor. You can see the example of activity storming. We have three ontologies for different views of the system: a static ontology, dynamic ontology, linked ontology. A static ontology is for a structural view, dynamic ontology is for behavioral view, and linked ontology for structural and behavioral views. The picture shows the syntax of YAML-DSL. The focus of level 2 is on the REST architecture. It contains resource-oriented concepts, and we have two models: dynamic security model and a static model. The framework transforms the CIM DSL to PIM models. Static and dynamic models have common elements, so we developed EOL rules for synchronization. As you can see, RESTful concepts are added in this level. Level 3 is a platform specific, and the framework merged PIM models and generated service model. The user can create deployment and configuration models too. The focus of level 3 is on the architecture: intra-application architecture and inter-application architecture. Intra-application architecture can be simple or CQRS. We developed transformation rules for both of them. You can see the simple one and you can see the complex one. It is inter-application architecture view. This level 4 contains models and DSLs of code generators. The framework transforms of a model of PIM into models of code generators. We developed EGL rules for transforming model to DSLs. You can see the model of Sculptor and JHipster and their DSLs. It is DSLs. Also, we proposed a framework for our methodology. First of all, we defined roles. In the proposed methodology, we have some primary rules and optional rules. Primary rules are user, product owner, coach, domain expert, developer, and other roles are optional. We developed a process for the proposed framework. This framework consists of 4 phases: a startup, construction, transition, maintenance. We explained all elements of this process in my master thesis. Evaluation and conclusions. We validated methodology through a case study and criteria-based evaluation. The case study is a gift card generator system, and it is an essential part of my study because I spent 3 months on my case study. Also, we have evaluated the proposed methodology by applying different criteria: general software development criteria, model-driven criteria, model-driven web engineering criteria, and RESTful web service criteria. The picture shows a part of questionnaire, and it demonstrates the quality of the framework, and it shows that is too high, 92% and 95%. During this study, we proposed a comprehensive methodology for developing RESTful web services, the framework and the process. And we introduced modeling levels and model transformations. we used textual requirements, and we started from textual requirements. We used domain-driven development concepts, and we provided rich domain model. Also, we supported common architectural styles and patterns such as microservice, event-driven architecture, and CQRS. We introduced some tools to support the framework better. In the future, we can use NLP method for textual requirements annotation. We can support other diagrams for domain modeling. We can cover strategic concepts of domain-driven development, and also we can support reverse engineering method. We can generate the model from code. I think it is the most important item. Thank you for attention, and you can find me on social media with @Amir Deljouyi.